Hello everyone. Today we will be talking about laboratory safety and regulations. Clinical laboratory personnel, by the nature of the work they perform, are daily exposed to a variety of real or potential hazards. As future laboratory personnel, we should develop an understanding of the risks associated with these hazards and be safety cautious at all times. Safety begins with the recognition of hazards and is achieved through the application of common sense, a safety-focused attitude, good personal behavior, good housekeeping in all laboratory work and storage areas, and above all, the continual practice of good laboratory technique. In most cases, accidents can be traced directly to two primary causes, the unsafe acts and the unsafe environmental conditions. Public Law 91596, or better known as the Occupational Safety and Health Act or the OSHA, was enacted by the U.S. Congress in 1970. Their goal is to provide all employees with a safe work environment. They are authorized to conduct on-site inspections to determine whether an employer is complying with the mandatory standards. OSHA standards that regulate safety in the laboratory include bloodborne pathogen standard, formaldehyde standard, laboratory standard, hazard communication standard, respiratory protection standard, air contaminant standard, and the personal protective equipment standard. Bloodborne pathogens. This standard applies to all exposure to blood or other potentially infectious materials in any occupational setting. It defines terminology relevant to such exposures and mandates the development of an exposure control plan. The exposure control plan includes exposure evaluation, engineering controls, work practice controls, and administrative oversight of the program. Universal precautions and personal protective equipment are foremost among these infection control measures. Universal precautions. The concept is basically an approach to infection control in which all human blood, tissue, and most fluids are handled as if known to be infectious for the HIV, hepatitis B virus, and other bloodborne pathogens. It also provides fairly detailed directions for decontamination and the safe handling of potentially infectious laboratory supplies and equipment, including practices for managing laundry and infectious waste. The hazard communication, or informally referred to as the OSHA HAZCOM standard, defines hazardous substances and provides guidance for evaluating and communicating identified hazards. They are intended to ensure that the hazards of all chemicals used in the workplace have been evaluated and that this hazard information is successfully transmitted to employers and their employees who use the substances. The primary means of communications are through proper labeling, the development and use of safety data sheets, and employee education. The occupational exposure to hazardous chemicals in laboratory are also known as OSHA lab standard. This is intended to address the shortcomings of the hazard communication standard regarding its application peculiar to the handling of hazardous chemicals in laboratories whose multiple small-scale manipulations differ from the industrial volumes and processes targeted by the original HAZCOM standard. To reduce or eliminate occupational exposure to hazardous chemicals, the lab standard requires the appointment of chemical hygiene officer and the development of a chemical hygiene plan. Chemical hygiene plan must detail engineering controls, PPE, safe work practices, and administrative controls, including provisions for medical surveillance and consultation when necessary. There are other regulations and guidelines, the federal regulations relating to laboratory safety. They are Clean Water Act, Resource Conservation and Recovery Act, and Toxic Substances Control Act. In addition, clinical laboratories are required to comply with applicable local and state laws, such as fire and building codes. Clinical and Laboratory Standards Institute. They provide excellent general laboratory safety and infection control guidelines in their documents, the GP 1783 and M29A4. The Joint Commission publishes a yearly accreditation manual for hospitals and the accreditation manual for pathology and clinical laboratory services, which includes a detailed section on safety requirements. The CAP, or the College of American Pathologists, publishes an extensive inspection checklist, or the Laboratory General Checklist, as part of their laboratory accreditation program, which includes a section dedicated to laboratory safety. Safety awareness for clinical laboratory personnel. Safety responsibility. The employer and the employee share safety responsibility. While the individual employee has an obligation to follow safe work practices and be attentive to potential hazards, the employer has the ultimate responsibility for safety and delegates authority for safe operations to laboratory managers and supervisors. In order to ensure clarity and consistency in safety management in the laboratory, it should start with a written safety policy. Laboratory supervisors who reflect the attitudes of management towards safety are essential members of the safety program. So what is the responsibility of the employers? So they establish laboratory work methods and safety policies. They provide supervision and guidance to employees. They provide safety information, training, PPE, and medical surveillance to employees. They also provide and maintain equipment and laboratory facilities that are free of recognized hazards and adequate for the task required. Employee conduct in the laboratory is a vital factor in the achievement of a workplace without accidents or injuries. Employees' responsibilities. Know and comply with the established laboratory safe work practices. Have a positive attitude towards supervisors, co-workers, facilities, and safety training. They should be alert and give prompt notification of unsafe conditions or practices to the immediate supervisor and ensure that unsafe conditions and practices are corrected. They are to engage in the conduct of safe work practices and the use of PPE. Signage and labeling. Appropriate signs to identify hazards are critical, not only to alert laboratory personnel to potential hazards, but also to identify specific hazards that may arise because of emergencies such as a fire or explosion. The National Fire Protection Association developed a standard hazard identification system. At a glance, emergency personnel can access the health hazard, fire hazard, reactivity, and special hazards. Each quadrant shows the magnitude of severity from 0 to 4. Manufacturers of laboratory chemicals also provide precaution about labeling information for users. So the labels in each chemicals, they provided statement of the hazard, precautionary measures, specific hazard class, the first aid instructions for internal or external contact, the storage code, the safety code, and personal protective gear and equipment needed if they use such chemicals. globally harmonized system of classification and labeling of hazardous chemicals, or the GHS. This system incorporates universal definitions and symbols to clearly communicate specific hazard in a single concise label format. Although not yet a law or codified as a regulatory standard, OSHA is presently working to align the existing hazard communication standard with provisions of the GHS and encourages employers to begin adopting the program. Safety equipment. The employer is required by law to have designated safety equipment available, but is also the responsibility of the employee to comply with all safety rules and use safety equipment. All laboratories are required to have safety showers, eye wash stations, fire extinguishers, fire blankets, spill kits, first aid supplies, and periodically test and inspect the equipment for proper operation. Chemical fume hoods and biosafety cabinets. Fume hoods are required to contain and expel noxious and hazardous fumes from chemical reagents. It should be visually inspected for blockages. Smoke testing is also recommended to locate no flow in areas in working space. Personal air monitoring should be conducted in accordance with the chemical hygiene plan of the facility. So this is how fume hoods looks like. Biosafety cabinets remove particles that may harm the employee who is working with potentially infectious biologic specimens. The Centers for Disease Control and Prevention and the National Institutes of Health have described four levels of biosafety, which consist of combinations of laboratory practices and techniques, safety equipment, and laboratory facilities. The biosafety level of a laboratory is based on the operations performed, the routes of transmission of the infectious agents, and the laboratory functions or activity. The BSCs should be periodically recertified to ensure continued optimal performance, as filter occlusion or rupture can compromise their effectiveness. Chemical storage equipment. Safety equipment is available for the storage and handling of hazardous chemicals and compressed gases. Safety carriers should always be used to transport glass bottles of acids, alkalis, or organic solvents in volumes larger than 500 ml, and approved safety cans should be used for storing, dispensing, or disposing of flammables in volumes greater than 1 quart. This is how a safety carrier looks like. Steel safety cabinets with self-closing doors are required for the storage of flammable liquids, and only specifically designed explosion-proof refrigerators may be used to store flammable materials. Only the amount of chemical needed for that day should be available at the bench. Gas cylinder supports or clamps must be used at all times, and larger cylinders should be transported with valve caps on using hand carts. PPE and hygiene. Eyes, skin, and respiratory and digestive tracts are the parts of the body most frequently subject to injury in the clinical laboratory. Safety glasses, goggles, visors, or work shields protect our eyes and face. Contact lenses are strongly not recommended to be worn in the clinical chemistry laboratory unless the additional protective eyewear is also utilized. Gloves and rubberized sleeves protect the hands and arms when using caustic chemicals. Polyvinyl or other non-latex gloves are an acceptable alternative for people with latex allergies. Neutral gloves offer a wide range of compatibility with organic solvents than do latex gloves. Laboratory coats, preferably with neat cuffed sleeves, should be full length and buttoned and made of liquid-resistant material. When working with manipulations prone to splash hazards, lab coats should be supplemented with an impermeable apron and/or sleeve garters. Proper footwear is required inside the laboratory. Shoes constructed of porous materials, open-toed shoes, and sandals are considered ineffective against spilled hazardous liquids. Respirators with high-efficiency particulate air or HEPA filters must be worn when engineering controls are not feasible, such as when working directly with tuberculosis or when performing procedures that may aerosolize specimens of patients with a suspected or confirmed case of TB. Training, maintenance, and written protocol for use of respirators are required according to the Respiratory Protection Standard. Biologic safety. All blood samples and other body fluids should be collected, transported, handled, and processed using universal precautions. Ideally, specimens should remain cupped during centrifugation or several minutes should be allowed to elapse after centrifugation is complete before opening the lid. Any blood, body fluid, or other potentially infectious material spill must be promptly cleaned up and the area or equipment must be disinfected immediately. Safe cleanup includes the following recommendations. Alert others in area of the spill. Wear appropriate protective equipment. Use mechanical devices to pick up broken glass or other sharp objects. Absorb the spill with paper towels, gauze pads, or tissue. Clean the spill site using a common aqueous detergent. Disinfect the spill site using approved disinfectant or 10% bleach using appropriate contact time. Rinse the spill site with water. Dispose of all materials in appropriate biohazard containers. Bloodborne pathogens. In December 1991, OSHA issued the final rule for occupational exposure to bloodborne pathogens. To minimize employee exposure, each employer must have a written exposure control plan. The plan must be available to all employees whose duties may result in reasonably anticipated occupational exposure to blood or other potentially infectious materials. In recent years, new and serious occupational hazards to personnel have arisen, and this problem has been complicated because of the general lack of understanding of the epidemiology, mechanism of transmission of the disease, or inactivation of the causative agent. Special precautions must be taken when handling all specimens because of the continual increase in the proportion of infectious samples received in the laboratory. Therefore, in practice, specimens from patients with confirmed or suspected hepatitis, acquired immunodeficiency syndromes, or other potentially infectious diseases should be handled no differently than other routine specimens. Adopting a universal precautions policy which considers blood and other body fluids from all patients as potentially ineffective is required. Airborne pathogens. Because of a global resurgence of TB, OSHA issued a statement in 1993 that the agency would enforce CDC guidelines for preventing the transmission of tuberculosis in healthcare facilities. The purpose of the guidelines is to encourage early detection, isolation, and treatment of active cases. TB isolation areas with specific ventilation controls must be established in healthcare facilities. Those workers in high-risk areas may be required to wear respirators for protection. All healthcare workers considered to be at risk must be screened for TB infection. Other specific pathogens, including viruses, bacteria, and fungi, may be considered airborne transmission risk. Protective measures in the clinical laboratory generally involve work practice and engineering control focused on prevention of aerosolization, containment or isolation, and respiratory protection of N95 or better. The shipping. Clinical laboratories routinely ship regulated material. The U.S. Department of Transportation or the DOT and the International Air Transport Association have specific requirements for carrying regulated materials. There are two types of specimen classification. First one is the known or suspect infection specimens are labeled infectious substances if the pathogen can be readily transmitted to humans or animals. Second one is the diagnostic specimens are those tested as routine screening or for initial diagnosis. Chemical safety. Last August 1987, OSHA published the new Hazard Communication Standard, which is the Right to Know law. The Right to Know law was developed for employees who may be exposed to hazardous chemicals in the workplace. Employees must be informed of the health risks associated with those chemicals. The intent of the law is to ensure that health hazards are evaluated for all chemicals that are produced and that this information is relayed to employees. To comply with the regulation, clinical laboratories must plan and implement a written hazard communication program and obtain safety data sheets for each hazardous compound present in the workplace and have the SDS readily accessible to employees. They should also educate all employees annually on how to interpret chemical labels, safety data sheets, and health hazards of the chemicals, and how to work safely with the chemicals. Should maintain hazard warning labels on containers received or filled on site.
Okay, let's continue with our report. We are now here in safety data sheet. So for those employees who may use hazardous materials in their field, safety data sheet is a major source of safety information for them. So the following are the information contained in the safety data sheet and must follow a specific format. So the following are the identification, the hazard identification, ingredients from information, first aid procedures, firefighting procedures, accidental release measures, handling and storage, exposure controls and personal protection, physical and chemical properties, stability and reactivity, toxicological information, ecological information, disposable considerations, transport information, regulatory information, and lastly is the other information including date of preparation or last revision. So let occupational exposure to hazard chemicals in laboratory is also known as the laboratory standard. So these provide laboratories with specific guidelines for handling hazardous chemical. So for handling hazardous chemical, we should not forget the chemical hygiene plan. So what is this plan? This plan provides the procedures and work practice for regulating and reducing exposure of laboratory personnel to hazardous chemicals. Hazardous chemicals are those that pose a physical or health hazard from acute or chronic exposure. So again, in order for us to be knowledgeable in handling the hazardous chemical, so training must be provided to all employees and must include recognition of signs and symptoms of exposure, location of safety data sheet, the chemical hygiene plan, and how to protect themselves against hazardous chemicals. So let's go on to toxic effects from hazardous substances. Toxic toxic substances have the potential of producing deleterious effects. So those are the direct chemical action and interference with the functions of body system. So toxic substances can cause acute or chronic effects related to the duration of exposure and can pose risk of damage to a worker's lungs, skin, eyes, or mucous membranes following long or short-term exposure and can be toxic exist. Okay, so exposure to toxic agent can be through direct contact, inhalation, ingestion, inoculations, or injection. So in clinical chemistry laboratory personnel should be particularly aware of toxic vapors from chemical solvents such as the acetone, chloroform, methanol, and carbon tetrachloride that do not give explicit sensory irritation warnings as the bromide, ammonia, and formaldehyde. Mercury. It is another frequently disregarded source of poisonous vapors. It is highly volatile and toxic and is rapidly absorbed through the skin and respiratory tract. Storage and handling chemicals. So the pictures shows the separation. So these are the storage requirements. So for the flammable liquids, it should be separated from flammable solids. The mineral also should be stored separately from organic acids, and caustic stored separately from oxidizer. Perchloric also acid is stored separately from water reactive substances, and air reactive substances stored separately from other things. So flammable combustible chemicals. These are used in numerous routine procedures, are among the most hazardous materials in the clinical chemistry laboratory because of the possible fire or explosion. So they are classified according to their flash point. So for a flammable liquid, it has a flash point below 37.8 degrees Celsius, and combustible liquids have a flash point at or above 37.8 degrees Celsius. So these are some commonly used flammable and combustible solvents. And those are the acetone, benzene, ethanol, heptene, isopropanol, methanol, toluene, and xylene. So corrosive chemicals are injurious to the skin or eyes by direct contact or to the tissues of the respiratory and gastrointestinal tracts if inhaled or ingested. For example, the acid like acetic, sulfuric, nitric, and hydrochloric, and bases like ammonia hydroxide, potassium hydroxide, and sodium hydroxide. So reactive chemicals are substances that under certain conditions can spontaneously explode or ignite, or that involve heat or flammable or explosive gases. So for example, some strong acid or bases react with water, no generate gases. So these are example exothermic. This is the exothermic reaction. And then hydrogen is liberated if alkali metals, sodium or potassium, are mixed with water or acids, and spontaneous combustions also may occur. Carcinogenic chemicals. Carcinogenic chemicals are substances that have been determined to be cancer-causing agents. For example, the benzidine. Let's go on to chemical spill. So it is important to know this area to avoid accident from chemicals. So to prevent chemical spill, strict attention to good laboratory technique is needed, and also emergency procedures should be established to handle any accidents. So if spill occurs, this step must do: assist evacuate personnel. So kung makita mo nga naka spill o chemical ang inyong kauban, dili lang ninyo siya tan-awon lang, hala, na-spill mo ang chemical. No, you should assist and evacuate the personnel. And then next is the confinement, and then clean up of the spill can begin. So this is the spill clean up kit. Next, the radiation safety. So, radioactive materials are used or stored must be posted with caution signs, and traffic in these areas should be restricted to essential personnel only. As part of routine procedures of environmental safety of radiation, regular and systemic monitoring must be emphasized. Decontaminations of laboratory equipment, classes, and work areas should be scheduled. So let's go on to fire safety. Fire is basically a chemical reaction that involves rapid oxidation of a combustible material or fuel, with the subsequent liberations of heat and light. So these are the elements essential for fire that are present in clinical laboratory: the fuel, the heat or ignition source, oxidation, I mean oxygen rather, and research suggests that a fourth factor is present, which is the reaction chain. Classifications of fires. So these are the classification. So for class A fires, such as the ordinary combustibles, wounds, paper and clothes, or etc. So the type of extinguisher that you will use is the pressurized water and dry chemical. For the class B fires, such as the flammable, liquid, grease, gasoline, paints, and chills. So the type of extinguisher that you will use is the dry chemicals and carbon dioxide. For class C fires, electrical equipment, motor switches. So extinguish the type of extinguisher that you will use is the carbon dioxide, the halon, and the dry chemicals. And also for the class D fires, use this type of agent is the metal X. So the operation that we will always remember para ma-safe ta in fire soon sa kung maka-encounter ta og mga fire. So the operation pass, we should always remember that word pass. So P is for pull pin, A is for the aim nozzle, and the S squeeze trigger, and the S is for the sweep nozzle. So control of other hazard. We have here the electrical hazard. So there are two hazards for electrical energy, the direct and indirect. So for direct, we have the death, shocks, burns, and for indirect hazards, can result in the fire or explosion. So precautions, these are the precaution procedures to follow in operating or working around electrical equipment. So use only explosion rated equipment in hazardous atmosphere. Be careful. Be particularly careful. Use only properly grounded equipment. Check for frayed electrical cords. Promptly report any malfunctions or equipment producing a tingle for repair. Do not work on live electrical equipments. Never operate electrical equipments with wet hands. So, dapat dry atong hands when using electrical equipments. Know the exact location of the electrical control panel for the electricity to your work area. The use only approved extension cord in a temporary application, and do not overload circuit. Bawal ang octopus nga connected nga mga wires. So have grounds, polarity, and leakage checks and other periodic preventive maintenance performed on outlets and equipment. So compressed gas hazard. So this is serve as a number of function in the laboratory, presents a unique combinations of hazard in the clinical lab. So the danger of fire, explosion, asphyxiations, and mechanical injuries. So several general requirements for safely handling compressed gases. So know the gas that you will use. Store tanks in a vertical position. So dili nimo siya ipahigda. Keep cylinders secured at all times. Never store flammables, liquid, and compressed gas in the same area. Use the proper regulator, tubing, and fitting for the type of gas in use. Do not attempt to control or shut off gas flow with the pressure relief regulator, and then so on and so forth. Okay, for mechanical hazard, in addition to physical hazard such as a fire, electric shock, laboratory personnel should be aware of the mechanical hazard of equipment such as centrifuge, autoclaves, and homogenizer. So like cleaning centrifuge. So dili ka mag kay kuya man na siya no. So dili nimo iana imo ka basig maputol pa lang no, simbak lang. And then autoclaves kay ini siya sa bawal ka. Be careful jud in handling mechanical hazards. So disposable of hazardous materials. So, for chemical waste, strong acid or base should be neutralized before disposal. Foul-smelling chemical should never be disposed of down the drain. Bawal nimo siya, dito lang sa drain nimo siya ilabog, no. It's a big no-no. So, other liquid waste, including flammable solvents must be collected in approved container and segregated into compatible classes. If practical, solvents such as xylene and acetone may be filtered or redistilled for reuse. If recycle is not feasible, disposal arrangement should be made by specifically trained personnel. So before disposal, hazardous substances that are explosive and carcinogen should be transformed to less hazardous form whenever feasible. So for radioactive waste, delikado ni siya, no? So the radiation safety officer should always be consulted about the policies dealing with radioactive waste disposal. And then for the biohazard waste, we have here the medical waste. It is defined as a special waste from healthcare facilities and is further defined as a solid waste that, if improperly treated or handled, may transmit infectious disease, and generators of medical waste must be implement the following procedures, such as employees of healthcare workers must establish and implement an infectious waste program. All biomedical waste rather should be placed in a bag marked with the biohazard symbols and then placed into a leak-proof container that is puncture resistant and equipped with a solid tight fitting lid. So that's why if we are going to have our like extracting blood in the laboratory, naadyo dito ang mga biohazard. So dapat diri ang kana siya, diri ang needle, diri kay if if we if magpataka lang ta og butang-butang ana, so naay possibilities nga makatransmit og mga uh, infectious diseases sa mga tao nga nakapalibot ana siya. So dapat we should be always careful in handling biohazardous waste. Also, all containers must be clearly marked with the word biohazard or its symbol. Na may mga symbols ana no nga we should know about that symbols. So all sharp instruments such as needle, like what I have said, blades and glass objects should be placed into special puncture-resistant containers before placing them inside the bag and containers. So that's all for chapter 2, and chapter 3 is next. Thank you.